Alright, so today we are going to be verifying identity. So basically we're going to prove something they give us is true. Okay, so the tips for doing this are, first, work with one side at a time. Okay, doing this makes it a lot simpler. So you want to start with the more complicated side. That way you can break it down. Okay, the second one is look for any of these things. Look for factoring, adding the fractions, and any of the identities that we've talked about or any that are on that laminated page. Okay. 3, use sine and cosine. So like before, when you have sine and cosine, it's easier if you simplify it to that, because sine and cosine are the easiest ones to work with. And 4, just try something. Don't give up right away. And yes, that is a tip. Okay, so with those tips, we're going to look at example 1. Okay, and also there are multiple ways to prove stuff, so if you get something different than what somebody else did, doesn't necessarily mean it's wrong. Okay, so example 1, secant squared theta minus 1 over secant squared theta equals sine squared theta. Okay, so I'm going to prove that this does indeed equal sine squared theta. Okay, so this is my more complicated side, so this is the side I'm going to focus on. Okay, if I look at the first one, secant squared theta minus 1, look at my properties. If I rearrange that second one under the Pythagorean identities, I get that this top is equal to tangent squared. So tangent squared theta over secant squared theta. Okay, and again, I'm just going to rewrite what I have on the right-hand side. Okay, now, tangent squared theta, that would be sine squared over cosine squared. Over, and then secant squared is 1 over cosine squared. Okay, then remember when you flip the second and multiply, I'd have times cosine. So I had sine squared theta over cosine squared theta times cosine squared theta over 1. My cosine squares would flip. Oh, don't forget this equals sine squared theta. So then when I cancel this out, I have that sine squared theta equals sine squared theta. Okay, so that is true. There's your proof. You use those identities, you use your knowledge to prove that was true. Okay, there's also other ways you could do this. So let's look at another way we could have done it. Start off the same way. So secant squared theta minus 1 over secant squared theta equals sine squared. Again, I'm starting with the left side because it's the more complicated side. I can split these up. I can write them as their own separate fractions. So secant squared theta over secant squared theta minus 1 over secant squared theta equals sine squared theta. Okay, if I do this, this becomes 1, and this becomes cosine squared. Okay, then if I look at my identities, and I look at the first one under the Pythagorean identities, rearranging this, this is sine squared theta. So sine squared theta equals sine squared theta. So if you look, both of them get us to the same point where we prove that it is true. Okay, so remember, there's more than one method that you can use. Alright, let's look at next example. I have 1 over 1 minus sine alpha plus 1 over 1 plus sine alpha equals 2 secant squared alpha. Okay, again, I want this to end up looking like this, so I know what my results should be. Okay, remember, when you're adding fractions, you can't add them together unless they have a common denominator. So in order to get a common denominator, I need to multiply the top one by 1 plus sine alpha over 1 plus sine alpha, and the second one by 1 minus sine alpha over 1 minus sine alpha. Okay, kind of wrote it to the side because I don't have a lot of room. Okay, when we do this, on the top of the first one, I get 1 plus sine alpha. And on the bottom, I get 1 minus sine alpha times 1 plus sine alpha. Okay, I know that's what's going to be on my bottom on both because that was the whole point. Okay, so this was the first, then I have plus my new top, so 1 minus sine alpha. Okay, going from here, my signs cancel. Okay, so I'm left with 1 plus 1, so that's 2 over 1 minus sine alpha times 1 plus sine alpha. I'm having issues writing. Okay, so then here, if I FOIL this out, so multiply it out, I get 2 over 1 times 1 is 1, 1 times sine alpha is sine alpha, plus negative sine alpha times 1 is negative sine alpha. Okay, then negative sine times sine is negative sine squared alpha. Okay, here our signs cancel, so I'm left with 2 over 1 plus, not plus because it's a minus, so minus sine squared alpha. Okay, now 1 minus sine squared alpha. Okay, this is where it gets a little bit trying to figure out where this goes. So looking at the Pythagorean identities again, the first one, if I rearrange that, that becomes cosine squared. So I have 2 over cosine squared alpha. Okay, now remember, cosine squared is, or anything over cosine squared that's reciprocal. If I flip it, it becomes secant. So this now becomes 2 secant squared alpha. Okay, so I missed this step where I'm writing these all out, because in the end we want to prove that it's true. So I'm just rewriting it. So equals 2 secant squared alpha. Check. We proved that it's true. Okay, I believe we have one more example, so I'm going to go ahead and flip this over. We have example 3. Tangent squared theta plus secant squared theta equals 2 secant squared theta minus 1. Okay, so this one is, they both seem kind of complicated. So I'm going to rearrange it to where I have all the secants on one side. So I'm going to minus secant squared theta from both sides. Okay, when I do that, I get tangent squared theta equals, so 2 minus 1 is 1, so secant squared theta minus 1. Okay, then from here, I'm going to rearrange it so that it looks like my first identity, not my first, my second identity under Pythagorean identity. So the 1 plus tangent equals secant squared. So add 1, so tangent squared theta plus 1 equals secant squared theta. Okay, well that's the exact identity, but it's just flipped. Okay, so I know that this right here equals secant squared. So secant squared equals secant squared. And there's our proof. Okay, your assignment for this is A5, page 387, numbers 1, 2, 5, 6, 12, and 19. Tomorrow you will have a work day, so if you're not understanding, please make sure you let me know so that we can get you some help. Good luck.